So let's now talk specifically about these IEC-61131 programming languages. So IEC-61131 is a standard originally published in 1993 that defines these 5 programming languages and the environments needed to program them. The languages are instruction list, structured text, ladder diagram, function block diagram, and sequential function chart. And in common usage, I'll usually just say IL, ST, LD, FBD, SFC, as you see those abbreviations. So here's the simplest language, instruction list. And this is a pretty low-level language. It's text-based. And you can think of it as a pretty simple machine language where each line is an instruction, like load a value, add a value, multiply a value. And each line just interacts with the value, give it, and the line before it. So you can see, here's a quick code snippet from instruction list, or you can imagine you just run through, evaluating that single line as you go down. So, it's kind of easy to understand line by line, but it can be quite tedious to make large applications and keep track when you have a lot of things going on at the same time. You got to keep calling back variables you've used before. The next text-based language is structured text, which is a more high-level programming language, similar to Pascal, which is a more normal computer programming language. So it has things like if-then statements with conditionals, while loops, for loops. It's easier to use variables and Boolean or logical operators. And all of the languages within FBX Designer are not case sensitive. Ignore white space. So you can kind of format it however you want with tabs and kind of code style. And structured text is really good for having more complex algorithms and calculations. So you can see here's a little code snippet where it's doing a lot more with less lines compared to instruction list, right? You can really do a lot with structured text that you couldn't really do in instruction list without a lot of effort. Let's go to the next slide. Next language, this is our first graphical language. So rather than typing out text, you have a graphical editor where you can kind of click and drag objects together. And here we have ladder diagram, which basically represents electrical relay logic. So you can see here we have these rungs where on the left you have like power being provided that goes from left to right through these contacts, which are inputs, on or off, which either allow or restrict the currents. And then on the right side we have coils, which you can think of as like a light or something, where if it receives, it's an output, where if it receives current, then that trips that output. So you can see it's just graphical from left to right. And within FBX Designer, you can combine ladder logic with these function blocks, which are these red blocks in the bottom. Which brings me on to the next slide, function block diagram. So in function block diagram, you have functions represented by these physical blocks, which take in inputs on the left and then output on the right. So you can imagine that data flows in from the left, gets executed by a function, gets output on the right, and then fed to the next function block on the right. So everything is run from left to bottom, top to right. And these can be combined with the ladder logic that we saw on the previous screen. So these are good for providing a good high-level overview of your program. And the red function blocks are firmware function blocks, while the green function blocks here are actually custom function blocks, where if you click on that custom function block, you can write what happens in that function block, and you can write that in any language you want. You can have a custom function block that consists of structured text or instruction list or even more function block diagram, and then put them inside your function block and then put that in your diagram. You can also make these custom function blocks and put them in structured text, and it would just appear as an extra line that says the name of your function. And then the last language is sequential function chart. And kind of like those custom function blocks, this is more a way of organizing your code. So the way this works is you have these steps. So you see these red, yellow, green are the name of my steps. And each step performs a series of actions, you see on the right. And these actions are actually custom functions, which you can write in any of those other languages, and then they're separated by these transitions, which again are custom functions, which you can write in any language. So this is just a way of modeling, what state your machine is at, what happens at that state, and then when it switches from this state to the next state and what it does there. So it's just a way of, high-level overview of structuring where you are and what code gets executed, but the actual code is written in those previous languages like function block, ladder, structured, or instruction list. And then here's a quick kind of comparison of of the four kind of basic languages, what the same type of logic looks like. So the example here is if you have three variables, A and B as inputs, C as an output, and if you want C to be true only if A is true and B is false, here's how you would do that very simple operation within these four languages. You can see the instruction list is 3 lines. You load A, you take the reverse of B and add that with A, and then you store that as C. Structured text is just C is equal to A and not B. So that kind of sounds more English, right? So structured text can be easier to read in that sense. Function block diagram is an AND block where the B input is negated. And then ladder diagram is you have 2 contacts in series. B is a reverse contact, and then C is your coil at the end of that. So you see, you can do the same code within all the languages, but it's kind of up to your preference and your coding style of which one you choose for a certain application.